Okay, so same thing, exercise 3K. I'm going to do a couple more examples, get you to practice your calculator and to do it algebraically. I think 2 and 3 might have been tricky for some if you know you're struggling with your algebra. But let's have a question 4. Question 4 should feel much easier to do. So let's say a quadratic rule for a particular parabola is of the form. Now the nice thing is they've given you the form. They tell you that it's y equals a times x squared. And then they say that the parabola passes through the coordinates 2 and 8. So that means when x equals 2, y equals 8. And that's beauty. That's easy to find a because you know that y equals 8. And you don't know what a is, but you know x has to be 2. Because when you sub 2 in, apparently it's meant to equal to 8 for the y value. So 2 squared, which is 4, you get 4a, and that's 8. And then a equals 2. True. Divide 4 on both sides and you get a equals 2. Now, that's how you do question 4 really, and that's very similar to the first one as well. Find the family of curves, sub it in, and simultaneous. Now I'm going to show you both question 1 and question 4, how you could have done it on a calculator. Okay, so question 1, same idea. Question 1, they've given you the form is y equals to ax squared plus c. And it says for the parabola in this family that passes through, and again it says when x is -1, y is 2, and when x is 0, y is 6, right? What I want to teach you is using the calculator to help you solve this problem. Now in the previous video, I showed you how to define and solve, true? It's really the bread and butter of most of your course for VCE Year 12. But let's do this whole thing again, okay? I'm just going to go back to menu, and I'm going to clear the things that I defined, okay? Clear A to Z. Now let's do it again. We're going to go to menu, 1, so actions, define. I want to define. Now what do I want to define? F of x, F bracket, x bracket, equals, okay? Now, what I want to do is I'm going to do question 1. Question 1 says, this is my equation. Now, f of x is really your y value, okay? So instead of saying y, we say f of x, and I'll show you why we do it, okay? So we call it f of x equals to a times x squared. So I'm going to go back to my calculator. I'm going to a times x squared. Now, it's important that you do that times button in between a and x. Otherwise, the calculator doesn't know the difference between ax. Okay, so you have to tell them this is a, it's a number, times x squared. Otherwise, you'll get it wrong. Okay, plus, what was it again? Was it plus c? Yes, ax squared plus c. Okay, so we'll go back, a times x squared plus c. True? What we would have done is when x is -1, y is 2. True? What you would normally do is you sub -1 in and say, okay, so -1 squared times a plus c has to equal to the y value, which is 2. Okay, so you get an equation, and it looks like this. You say 2 equals 2, sub -1 in, and you get a times -1 squared plus c, and you end up with 2 equals a plus c. True? And then you would do the same for the next one. You sub it in when x is 0, y is 6. So you get 6 equals a times 0 squared plus c, and you end up with 0 plus c equals 6, and c equals 6. Okay, and if c equals 6, well then you can find out a, because the equation here, you can sub c back in, and you get 2 equals a plus 6, minus 6 on both sides, so a has to equal to -4. Okay, now what I just did with you there is I did question 4 and question 1 by hand. Okay, I substituted the coordinates in, and I figured out a and c, but you can do this on a calculator. Okay, so I should get 2 answers. I should get c equals 6, which is here, and a equals -4. Now let's do that. These are our 2 coordinates. Now the benefit of doing f of x is now we're going to do solve. So we're going to go to menu, 3 algebra, solve. Okay, so 1, solve. And we're going to go to this button here in between 9 and the book. And these are the common uses. Now we've got 2 equations. We've got 2 coordinates, yeah? So I'm going to put it in. And so see, the nice thing using f of x is you can say what x values you're going to have. And in our case, the coordinates was when x is -1, y is equal to 2. So that's what I'm going to do. I'm going to say f of -1. So that means subbing x equals -1 in. Okay, and you can tell because what you're actually doing is you're saying that x, you're replacing it with a -1. So that means you're putting a -1 into the equation. That's why we like to use f of x, okay? So I'm going to put a -1 in. I'm just going to block this out. Uh-oh, what happened? Okay, cool. F of -1 equals 2, and where's my, here we go, 2. So that's really just saying if you sub in x equals -1, y is equal to 2. Okay, because remember, f of anything is really the same thing as saying your y value. So y equals 2. Next one, I say that I'm going to substitute 0 when x is 0, y is 6. So that's what I'm going to do. F of 0, y equals 6. 6. Okay. Now what am I solving for? I'm solving for a and b. Now notice where my cursors are. I would have to, if you can't just do a comma here. You have to move the cursor to the right, and it's like in this big bracket. You say, all right, I want to comma, solve for a, comma, solve for c. Okay, so you're really doing what I just did here. I substituted -1 in, sub 2 in, sub 0 in, and sub 6 in, and I solved for it, right? Well, instead of doing it manually, you can do it on a calculator in 2 steps. Bam, a equals -4, and c equals to 6. Same drill. Yeah, let's do it again. Let's do it for question 4. So don't forget question 4. This was my equation. So that right there, y equals ax squared. So I'm going to do the same here. I'm going to say again, define f of x equals to a times x squared. Okay, don't forget that times. That times in between the a and the x is important. Done. Okay, so I've defined what f of x should be. Now I'm going to say solve. Same thing again, but in this case, you only got one coordinate to solve because you only got the letter a to solve. There's only one unknown, whereas in question 1, you can see that you had a and c. Yeah, so because there's a and c, that's why you need 2 coordinates. In our case here, we only got a, we only need 1 coordinate. So let's look at question 4 again. The 1 coordinate was when x equals 2, y equals 8. So that's what I'm going to do. I'm going to say solve for, bracket, f of, apparently if I sub in 2, f of 2 equals to, my y value should be 8, comma a, because I'm trying to solve for a. 2 steps. A equals 2, and that's what I had when I was solving it before as well. See? A equals 2. Okay, so I'm trying to teach you how to do it algebraically, but you can also do it graphically on the graphics calculator. Yeah, and the only 2 skills I used was define and solve. Cool? Saves a lot of typing. Okay, let's see if I can do 5 just so you can see. Is this something I can do using a calculator? Yes. See, a quadratic rule for a particular parabola is of the form. They give you a form. That's the nice thing. They give you the equation. They tell you it is y equals ax squared plus bx. So that's what I got. I got y equals to a times x squared plus bx. Right? So I'm going to just clear this out. So right click it, clear history. I'm going to do the same thing again. Define space f of x equals to, and in my case here is a times x squared plus b times x. Again, importance, b and x, in between it you have to have the times, otherwise it's not going to work. Okay, so I define it, and now what does that tell me? It says the parabola passes through the points with coordinates -1, 4. So that means when x is -1, when x is -1, y is equal to 4. So I can say, all right, that's one equation. But remember, you also got 2 unknowns, so you need another coordinate. And it says, and one of its x-axis intercepts is 6. Now we know that to find your x-axis intercept, if x is 6, then y has to be 0. Yeah, anytime you want to find x-intercept, you let y equal to 0. So I do have a coordinate. I got another one when x equals 0, 6, y equals 0. So that's my second equation. So here we go. We're going to then solve. So again, menu, go back to menu, 3, 1. And here, I'm going to choose my 2 equations because I got 2 coordinates. It's when f of, let's go, f of, it says when x is -1, y is 4. So I'm going to do -1 equals to 4. Second one is f of 6, sorry, when x is 6, y is 0. So when x is 6, it's equal to 0. Now, when I'm done, move the cursor to the right and we're saying solve for a and b. So comma a, comma b. That tells the calculator to solve it. When you sub -1, y gets 4. And when x is 6, y gets 0. Solve for a and b. So this is my answer here. Should be 4 and 7 and negative 24 and 7. Let's see if I can do this by hand. See if it's the same. Okay. So according to this equation, if I sub negative 1 in, I should get 4. So I'm going to follow the same thing, but I'm going to do it by hand this time. So here we go. Y is 4 when I sub in negative 1. Did I put negative 1 before? Negative 1, yeah, that's good. Negative 1 squared plus b times negative 1. And this gives me a, because negative 1 squared is 1, minus b is equal to 4. That's my first equation. The second thing is I substituted again when x is 6, y is 0. So I have a second equation, y is 0 when I sub in 6. So 6 squared plus b times 6. And we can work this out to be 36a plus 6b is equal to 0. That's my second equation. Okay. And because that's my second equation, then now I can try to do elimination method or substitution. Up to you. I like elimination method. I've always liked elimination method. It's just quicker for me. What I can see is if I have 6 of these b's, it'll be good because I can just add them and it'll cancel out. So I'm going to say times this equation by 6, times that by 6, times that by 6. Yeah, because if you times everything by 6, it stays the same quantity. Or ratio anyway. Okay, so this now becomes 24 is equal to 6a minus 6b. And this is still my same equation. That 0 is equal to 36a plus 6b. Now see how they're both the same. That's 6b and that's 6b. If I said add these two equations together using elimination method, then 24 plus 0 is 24. Adding vertically down, 6a plus 36a would give you 42a. And then finally, negative 6b plus 6b, well, of course, that cancels out. And that's what I wanted. So that now gives me 42a is equal to 24. Divide both sides by 42. A equals 24 on 42. And as you can see, a equals to, simplifying this down, 6 into 24 is 4. And 6 into 42 is 7. So a equals 4 and 7, which is exactly what I got over here. See, look, a equals 4 and 7. Okay, how do you find b then? Well, according to our equation, which you can sub it in anywhere, if a equals 4 and 7, you can go back here and substitute it in. So 4 equals to a minus b, but since we know a is equal to 4 and 7, so this is 4 and 7, this is 4 minus b. And what we can see is I personally just like to add b on both sides, because then this b cancels out. You get b plus 4 equals to 4 and 7, and then minus 4 on both sides, so minus 4 cancels out, and then 4 and 7 minus 4. And this is up to your fractions here. That's the same thing as saying 4 on 7, take away 4 on 1. To get the same denominators to add and subtract, times this by 7, times this by 7. 4 on 7 minus 28 on 7. So how many 7s do I have? 4 minus 28, negative 24 on 7, which is exactly what they got as well. Okay, so you can do it by hand, but you see I did it all in 2 steps. Cool? So you can do it calculator and you have to be able to do it manually as well. Okay, so I just did question 5 there. I'll do 6 while we're here too. So let's have a look at 6. Let's look at 6. Let me just move this down a bit further. Here we go. Question 6. The quadratic rule. So in this case, they gave you the quadratic rule again. I'm more interested in questions where they don't give you the rule. But in this case, because they give you the rule, it's actually really easy to do. So you got y is equal to a times x minus b all squared plus c. Now the parabola has a vertex of 1, 6. Vertex means turning point, and hopefully you've learnt a lot with me about how to read the turning point. If it's 1, 6, so it means goes to the right by 1, up by 6, then we know C has to be 6 because it's going up by 6, and we know that B, because it's going to the right by 1, it has to be x minus 1 all squared. Okay, yeah, and then they tell you that the point coordinates that they like another coordinates when x equals 2, y equals 4. Okay, so right now all I know is this is my equation so far based from the turning point, because they said turning point is 1, 6. Then I already know that it has to be a x minus 1 squared plus 6. So this will, reading from exercise 3D, this will be implying to the right by 1 and up by 6. Okay. And now how do you find a? Same thing again. They told you when x equals 2, y equals 4. So you just really substitute in 4. This is a. X is 2, so 2 minus 1 squared plus 6. And 2 minus 1 is 1, 1 squared. So that's a plus 6 equals 4. Minus 6 on both sides, so a has to equal to negative 2. Okay. Now you can again do it on your calculator. This is a bit trickier because you have to know that the turning point 1, 6 tells you what B and C is. Okay, otherwise you can't solve it because you've got 3 unknowns and they only gave you 2 pieces of information. They said vertex and 2, 4. Doesn't really help you if you only got 2 coordinates to find 3 unknowns. So what you actually had to know was the turning point using exercise 3D allows you to find out B and C. Okay, so if I were to answer the question, same thing again, I can do define. Now remember, it doesn't have to be f of x, it could be g of x if you wanted to. I just use f of x because that's what we're used to as our convention. But g of x is equal to, now the question was a times bracket x minus, we knew it was 1 squared plus 6. Okay, that's what we knew. What we needed to find was a, right? Then you can say solve again, and in our case, instead of f, we use g. And they said if x is 1, y is 6. I say when x is 1, it's meant to go to 6, solve for a. See what I'm doing? Wait, that doesn't make sense. 1, 6. Oh, no. I was meant to sub in the other coordinate. When x is 2, y is 4. Sorry, my bad. Solve g of when x is 2, y is 4 for solve for a. The reason why it says it's true because I use the turning point, which is when x is 1, y is 6. Of course, it's going to be true because then sub 1 in, it cancels out, it becomes 0. So what I needed was a coordinate, and the coordinate was 2, 4. So when x is 2, y is 4, solve for a, and you get a equals negative 2. Just the same thing as I did it by manually. Okay. All right. Now let's jump to 14 and 21. 21 is pretty easy all by calculator. You can do this all by hand as well. So notice they say find the equation of the quadratic, and they didn't tell you it's x intercepts and they didn't tell you it's a turning point. And remember I said there's only 3 types of equations you need to know. And I wrote it up somewhere over here. Did I write it up? No, maybe I didn't. No, I did. Here. So previously I said these are the 3 equations that you have to remember. If you get a turning point, you use a turning point form. If you get x intercepts, you use this form. And if you get none of these, if you don't have a turning point, you don't have x intercepts, like 2 x intercepts that is, but you got 3 pieces of information, which is like coordinates, then you have to use this. Reason why is because there's A, B, and C. 3 unknowns, you need 3 things to find it out. And in our case, in question 21, conveniently, they gave you 3 coordinates to solve it. So that means y, you're going to have to use y equals ax squared plus bx plus c. Now the pain to this is if you were to do it by hand, it's such a pain. Because what you're going to be doing is you're saying, okay, when x is negative 2, y is negative 1. So using this equation that I have over here, then you would say that's negative 1 equals a times negative 2 squared plus b times negative 2 plus c. Yeah? This simplifies down to 4a minus 2b plus c. True? And then if you go to the next coordinate, they tell you when x is 1, y is 2. Yeah? Then that means now this is 2 equals to a times 1 squared plus b times 1 plus c, and that simplifies down to 2 equals to a plus b plus c. So now I've got my second equation. This is my first equation. And then my last point, which was when x is 3, y is negative 16. So negative 16 equals to a times 3 squared plus b times 3 plus c. And you can already see this simplifies down to 9a plus 3b plus c equals negative 16. And can you see what a pain it is to try to solve for this already? Okay, you got 3 unknowns, 3 equations. You have to simultaneous equation to figure it out. That's why it takes a long time to do this. But with the calculator that I just shown you, it would have been like 2 steps. Okay, so here we go. Let's try to solve this with 2 steps. Okay, so I'm going to delete all this again. What's going on? Here we go. Define, I'm going to do f of x again. F of x equals to a times x squared plus b times x plus c. Don't forget that b in between x has to be a times. If you don't put a times there, it's not going to work. So I defined it. Okay, that's my equation. What do I want to solve? I got 3 equations, 3 unknowns. Yes, again, menu, 3, solve. Okay, I've got 3 things. So between the 9 and the catalog, there are 3 informations here. Not information, or 3 equations to input, right? So here we go, 3 things that I can input. I know instead of typing the whole equation again like I am in every one of these, that takes too long. And that's why defining makes it easy. You see, now all I have to do is just say f of when x is equal to -2, y is -1. That's the first coordinate, yeah? So when x is -2, apparently y is meant to equal to -1. Okay, that's my first one. Second one was when x is 1, y is 2. So when f of 1, 2. Third one, I subbed in 3 and -16, yeah? So when f of 3 equals to -16. And comma, what am I trying to solve for? A, I'm trying to solve for B, I'm trying to solve for C. So comma A, comma B, comma C. See, 2 lines. There you go. Get your answer straight away. Okay, question 21 is very simple, very straightforward if you use a calculator. Otherwise, all right, we can do this by hand too. Just for those who are sort of interested in doing it by hand, I'm going to call this equation 1, equation 2, and equation 3. Yeah? What I'm going to do is I'm going to eliminate the C, because you can see C and C, they're the same quantity. So what I'm going to say is let's take equation 1, take equation 2, and say minus equation 1. Okay, so if I do that, I've got this 2 equals to a plus b plus c, and I've got -1 equals to 4a minus 2b plus c. Yeah, so that's equation 2 on the top line, equation 1 on the bottom line. Now if I minus them, minus everything, so 2 minus -1 becomes 2 plus 1, which is 3, because 2 negatives make it positive, right? A minus 4a, which makes it -3a, okay? B minus -2b, so 2 negatives become positive, so that becomes plus 3b, but then c minus c cancels out to be 0. So now I've got myself a new equation, which I'm going to call it equation 4, okay? So this is 3 equals to -3a plus 3b. I'm going to call this equation 4. That's nice, okay? I've got a and b there. All right. Now I need to have another equation simultaneous with 4. So what I can see is let's do something with the 3. Maybe do same thing again. Quantity C and these two are the same. So maybe I'll do 3 and 1. Let's do equation 3. Subtract. Should I subtract? Yeah, subtract. Equation 1. So here's equation 3. It was -16 equals 9a plus 3b plus c. And I'm minusing this from equation 1, which is -1 equals 4a minus 2b plus c. Let's work that out. -16 minus -1, which makes it +1, so -15. 9a minus 4a, which is 5a. 3b minus -2b becomes 5b, and c minus c becomes 0. So here's my new equation. I've got another new one, -15, 5a plus 5b. Cool. And I'm going to call this equation 5. Right? Finally, now I'm going to do the same thing. I'm going to simultaneous these two. Question 4 and 5. So let's have a look. 4 and 5. None of the quantities are the same. This has 5a, this has -3a. This is 5b, and that's 3b. So you have to multiply them or have them to have the same quantity. So what I'm going to do is the lowest common multiple between 3 and 5 is 15. So I'd have to times this by 3, times this by 3, times this by 3, and then times this by 5, times this by 5, times this by 5. Okay, if I do that, what I get now is I get 15 equals to -15a plus 15b. And on this one, this is -45 equals to 15a. Oh, that's not good. And this is 5, That's plus 15b. Oh no, that's all right. Okay, cool. So I've got these new equations here, and what I can see is they now have the same quantity. There's 15a here, that's 15a there, and that's 15b, and that's 15b. And it's so much easier if I just said, take this equation, this entire equation, plus with this equation. Why plus? Because I know it's going to cancel out the a's. 15a plus a negative 15a is going to cancel out. True? So I'm just going to write this equation over here. I've got 15 is equal to negative 15a plus 15b. Now I'm going to decide to add them. Okay, I'm going to add them. I'm going to add these two equations, and what you can see is if I add them, negative 45 plus 15 is negative 30. 15a plus negative 15a cancels out. Okay, so that's what I meant. It cancels out, you get 0 there. Then 15b plus 15b is 30b, and you can already see 30b is equal to negative 30. Divide 30 on both sides, b equals negative 1. Finally got one of the terms. So b equals negative 1, and if you have b equals negative 1, you can now try to solve for one of them. So let's take this original equation again. Remember number 4? Number 4 equation was 3 equals negative 3a plus 3 times b. But since b is negative 1, you got negative 3a plus 3 times negative 1. And that now gives me 3 is equal to negative 3a minus 3. Add 3 on both sides. So add 3, add 3. Negative 3 plus 3 cancels out, so you get 6 equals negative 3a. Divide both sides by negative 3, and you get a equals negative 2. So now you got a and you got b, then you can go back all the way to one of these equations to solve. And I'll probably put it back into equation 2 because it looks easier. You only got what? 2 is equal to a plus b plus c. And I'm only missing c. So a was equal to negative 2 plus b, which is negative 1, plus c, which I don't know. So this works out to be negative 2 minus 1 plus c. And negative 2 minus 1 is negative 3. So add 3 on both sides, and you can see c equals 5. And let's check if that was correct on my calculator. There you go. C equals 5, b equals negative 1, a equals negative 2. So you can do it by hand, but can you see how many steps you got to do? And it is expected at the year 11 level that you have to be able to do simultaneous equations of 3 different linear equations. That was a year 10 skill. I know it's not that everyone's mastered it and everything. It is tedious. It does take a long time, easy to make mistakes, but it is a requirement. It could come up in the exam, and you have to be able to do it without a calculator. But I'm teaching you both. I'm showing you how to do both. You can do it with a calculator, and you can do it by hand. By hand's a pain. If you know your algebra is good, then just work on your calculator. It takes only 2 steps. Yeah. Be efficient with it so that if you do get it on the exam multiple choice question, bam, you get your answers very quickly. But learn to define. Learn what I'm teaching you. Use the define button. Don't try to do it without it. I know some of you think like it's a waste of time. Trust me, it is so much quicker to do it this way. Okay, so you got define and you got solve. I will show you more calculator work, but these are the first 2. There's generally 3 as your bread and butter, and you'll be able to do the entire course with 3 functions. But just to start off, I'm showing you define and solve, and I'll show you another one as we're doing applications, so exercise 3L. Okay, so that was question 21, but I remember there was another question I haven't gone through. 14. Here we go. Let's have a look at 14 for exercise 3K here. 14. Now, this is all about identifying the graphs. So remember I gave you those 3 graphs. You have to look at key points. X intercept, y-intercept, yeah, turning point, shape of the graph. Those are all hints on what the graph looks like. So for example, in this question here, it says, which of the curves could be most nearly defined by each of the following? There are 4 equations up here, A, B, C, and D, right? And you have to figure out which one it should represent. Now, the first thing I look for is, these are smiley face graphs, true? So that means the equations have to have a positive x squared. This has a positive x squared. This one, if you do x times a negative x, that becomes negative x squared. So that's a frown shape. This is a smiley shape. And if I look at this again, you're squaring the x value, that becomes x squared. So it's a smiley face. Whereas this one, so you have to look at it, you're not squaring anything. It's already in a negative x squared. So that's a frown. Okay, so I already know that B and C could either be B and D. True? Okay, but the nice thing is C is easy to read because what I taught you in exercise 3D, and if you've forgotten, watch the video again. Y equals negative 10 plus 2 bracket x minus 1 squared. I taught you to read the turning point. So you can read this now. You can see that means down 10. And this means to the right by 1. That's a smiley face and it's narrow. So which one has a turning point where it goes to the right 1 and it goes down 10? So it goes down 10. So your turning point should be at 1, negative 10. So let's have a look at the graph. Which one looks like a smiley face? 1, negative 10. This doesn't look like it has a turning point at 1, negative 10. The turning point looks like it's here. See, that's 1. This is a bit further. So this must be D. C must equal to D. So that means B must equal to B without even calculating it. You see what I mean? Like without even figuring it out, I know this had to be B just by looking at it. But let's say if you didn't know, then the other way that you could do it as well is look at the y-intercept. You see, like if you look at this, y-intercept is 2 already because when you sub x equals 0, and for all of them, well, most of them, this one has a different y-intercept, and this is the only smiley face with a y-intercept of 2. So clearly you would have known that had to be B. B goes with B. Yeah, little b goes with B. So this is little b. D was with little c. Okay, because you can tell by looking at the y-intercept on the graph, the y-intercept is here for a smiley shape. This is a smiley shape, but the y-intercept is at negative 8. So clearly little b had to be big B, right? Now the question is, A and D, which one belongs to which? True, they're both rounds, but again, this one you can see 1/3 of x plus 4 and 8 minus x. Remember, you can find x-intercepts and y-intercepts. Now let's have a look. If you want to find x-intercepts, you can let this equal to 0. It's already factorized. It's 1/3 multiplied to x plus 4 multiplied to 8 minus x. So using null factor law, you already know this is 1/3, but multiplied to this could equal to 0 or this could equal to 0. So if x plus 4 had to equal to 0, then x would have to be negative 4. And this one would be 8 minus x. If it were to equal to 0, x would have to equal to 8. So where and which one of these graphs have an x-intercept at negative 4 and 8? See, this one clearly doesn't look like it's got x-intercept negative 4 and 8. This one, on the other hand, it's a frown, but it looks more, it's larger than 5, so this has to be 8. It's in less than 10, and this has to be negative 2. Oh, negative 4, sorry. Negative 4, somewhere there. All right. I don't know why that says negative 5 here, actually. That's weird. That should be a mistake. I don't know what that negative 5 is there for. It's likely that, what I'm trying to say is likely that C is your A. The little a represents C. But let's say you didn't know. Let's say you're still unsure. Then you can read the turning point for D. See, D, if you have a look at little d, D has y equals to half multiplied to 9 minus x squared. Oh, wait. Sorry, let me just fix that. Y equals to half of 9 minus x squared. Now, this is already a minus x squared. It's not square on the outside. It's already on the x. So if you expand it, this really is just 9 on 2 minus half x squared. So reading the turning point form, you can already see that means up, because it's positive 9 on 2, up by 9 on 2. It's a frown, wide, half makes it wide, so it's wide, and clearly it doesn't move left or right, because what you're squaring is the x. If you let that equal to 0 using my technique, it doesn't move left or right. So it's right in the center, and it goes up by 9 on 2. So right in the center and up by 9 on 2. 9 on 2 is 4.5, which makes more sense that this is your little d. True? Okay, that's another way of sort of reading it. So I already know the answers are, this represents little d, little b, little a, and little c. Okay, but yeah, the skill of exercise 3K, like I said, it's about analyzing what you're given. See, all the questions I've done, you have to look for x-intercept, y-intercept, turning point. And that goes back to the 3 equations I gave you earlier on, these 3. 3 pieces of information, and you decide which ones you have, okay? Look for turning points, look for x-intercepts. Those are big keys on how to read the type of equations you got. And it helps you to solve it too. Okay, so that's exercise 3K. I think I've sort of done quite a number of examples. Hopefully that's been enough for you to sort of get a gist of 3K. Okay, so I'm going to pause the video here and I'm going to go on to probably back to 3J or 3L. I might do some examples from 3J with a calculator so you can sort of know how to do it. Okay.